Okay, in this screencast, we're going to talk about arithmetic sequences and partial sums. So a sequence is arithmetic if the difference between any two consecutive terms is the same. So that means that if I take the second term and subtract the first term from it, I get a number. And if I take the third term and subtract the second term from that, I get the same number. If I take the fourth term, subtract the third term, I get the same number. So, and so on and so on. So if I could take any two terms that are next to each other and subtract, and I get the same number d, that's called the common difference. In other words, to get each term in the sequence, I'm just adding the same amount each time. So what's the common difference of this sequence? Well, 12 minus 8 is 4, and 16 minus 12 is 4, and 20 minus 16 is 4. So you can see the pattern here. So d is 4. So what if we just have a formula? We don't have the terms themselves. Well, we can use this formula to get the different terms. So a sub 1 is 5 minus 7 times 1, which is negative 2. A sub 2 is 5 minus 7 times 2, which is 5 minus 14, which is negative 9. A sub 3 is 5 minus 7 times 3, which is 5 minus 21, which is negative 16. So what's the common difference? Well, to get from negative 2 to negative 9, I subtract 7. To get from negative 9 to negative 16, I subtract 7. So d is negative 7. Okay, so now we come to the formula for the nth term of an arithmetic sequence, and this is only true for an arithmetic sequence. Okay, so the nth term is given by the first term plus n minus 1 d. And that's pretty important to remember. So you guys need to memorize that, okay? A sub n is a sub 1 plus n minus 1 times d. So to find the nth term of an arithmetic sequence, you need two things. You need the first term and you need the common difference d. So here's how we can use this formula. What's the 15th term, so there's n, of the sequence 3, 8, 13, 18. Okay, so our common difference, it looks like, is 5, because 8 minus 3 is 5, 13 minus 8 is 5, and so on. So there's d, and our first term is 3. So we have everything we need. The 15th term is the first term plus 15 minus 1 times d, which is 3. So it's going to be 3 plus 14 times 3, which is 3 plus 42, which is 45. So that's a pretty handy formula because you don't need to count out 15 terms to get to it. And if someone asks you to find the 100th term, well, who wants to write out 100 terms of a sequence? You can go straight to that 100th term using this formula right here. Okay, well, what if you don't know the first term? Here's a problem where we know the fourth term, a sub 4, is 20, and the 13th term is 65, and we're supposed to write the first 10 terms of the sequence. All right, well, let's use what we know. 20 is equal to a sub 1 plus 4 minus 1 times d, because remember that n is 4 when we have the 20th term. I'm sorry, when we have the fourth term equal to 20. We also know that 65 is equal to the first term plus 13 minus 1 times d. So simplifying this a little bit, I get that. And over here, I get 65 is a sub 1 plus 12d. Okay, well, let's solve this for a sub 1. 20 minus 3d equals a sub 1. And then I'm going to take this, and I'm going to plug it in for a sub 1 there. And that'll let me find d. So here we go. 65 is equal to 20 minus 3d, because that's what a sub 1 is equal to, plus 12d, or 20 plus 9d. Okay, so if I subtract 20 from both sides, I'm going to get 45 equals 9d So D equals 5. All right. So now we know D. Let's get a sub 1. Well, remember that 20 minus 3D is a sub 1. So 20 minus 3 times 5 is a sub 1. So 20 minus 15 is a sub 1. So a sub 1 is 5. Now we're ready to get our sequence. All we need to do is start with a sub 1 and add our common difference 10 times. So we're going to get 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And there are the first 10 terms of the sequence whose fourth term is 20 and the 13th term is 65. So what happens if I have an arithmetic sequence and I'd like to add up all those terms and see what the sum of them is? Well, we have a nice little formula for that. The sum of n terms of an arithmetic sequence is n over 2 times the first term plus the last term. So you need three things. You need to know how many terms you're adding up. You need to know the first term in the sequence and the last term. Okay? So let's try that with a problem. Find the sum of all the integers from 1 to 100. Okay, so that means we're going to go the sum of the 100 integers from 1 to 100 is the number of terms over 2 times the first term plus the last term. And that works out to 50 times 101, which is 5,050. So if I added up 1 plus 2 plus 3 plus 4 all the way to 100, that would equal 5,050. Well, what if you don't know the last term? For example, find the 150th partial sum of the arithmetic sequence going on here. Okay, so remember we need the first term, which we have. We need the number of terms, which we have. And we need the 150th term. Okay, well, we're going to use our old formula for the a sub n. That means we do a sub 1 plus n minus 1 times d. And 16 minus 5 is 11. So the 150th term is going to be 5 plus 149 times 11. And I'm going to get my calculator up here. And let's see, that's going to be 5 plus 149 times 11. 1644. Okay. So the 150th term is 1,644. Now we're ready to find the sum of the first 150 terms. So that's going to be the number of terms over 2 times the first term plus the last term. That will equal 75, 150 divided by 2 times 1,649. And let's work that out on our calculator. 75 times 1,649. Okay, big number. 123,675. Okay,